Refrigeration is really important for maintaining the quality of perishable goods. One big weak spot on this front is maintaining ideal storage conditions when goods are in transit from one place to another inside trucks. In fact, interrupted or incorrect temperature control is the cause of over one third of food spoilage in the world. This represents billions of dollars in losses every year. So, maintaining the correct temperature in transit is the challenge of cold chain logistics. The temperature and conditions inside a delivery truck can vary a lot, depending on the number of times it's opened to make deliveries, the weather outside, and also because of equipment malfunctions. It is therefore important to monitor the conditions inside a delivery truck at all times, so that anytime there is a shift from ideal storage conditions, these can be immediately flagged and corrected. This is where we enter the realm of data and data engineering. A real time monitoring system like this would require us to combine data from different streams that record information like the GPS, temperature, pressure, etc. But the challenge is that this information is coming from sensors that record this information and send them at different points in time. So combining them is not a straightforward task. These are the types of challenges that companies spend a lot of data engineering time and resources to solve. These often subpar solutions involve wiring together complex data pipelines and microservices to build really fragile systems that require a lot of maintenance and implementation costs. If you or your team face similar challenges, then this is the video for you. So here's the good news. You don't have to suffer through inadequate or imperfect solutions that don't really fit the needs of really complex streaming workloads. Instead, you can use a scalable tool like Kinetica to build flexible real-time monitoring systems that don't require complex data engineering. And all of this can be done with just SQL. For this demo, I caught up with Matt Hawkins, who showed me how to build a real-time monitoring system that continuously tracks the location, pressure, and temperature of multiple delivery trucks simultaneously. This monitoring system uses an ASOF join along with a materialized view to continuously perform inexact joins and recalibrate based on new incoming data. This information is then fed into a real-time dashboard that is built using Kinetica's inbuilt dashboarding app, Reveal. And all of this is done with just some simple SQL statements. Kinetica handles all of the complexity under the hood while delivering blazing fast performance on top. The code and the setup for this demo are provided in the video notes below. So if you want to, you can go ahead and reproduce this on your own. So now let's jump into this demo. Hey, Matt. So thank you for agreeing to do this demo.
No
do you want
problem.
to tell us a bit about what are you going to be showing us today?
Yeah, sure. So we're going to be talking about ASOF joins and how they can be used to join together two different data sets, which are on slightly different timelines in this example. So the sample data sets that we're going to be using is a real-time feed of vehicle locations, essentially like location breadcrumbs, which will have latitude and longitude, an X and Y location, unique identifier for that vehicle, and with some timestamps to register that location and space and time for that entity. We're also going to have a data set which is metrics around those vehicles. So when we put together this demo, we thought like in the context of things like temperature controlled trucks, for example, where you're collecting potentially metrics on things like temperature, pressure, voltage, et cetera, all the kind of workings of the vehicle. And these two data sets exist on separate timelines. You've got the sensors generating the metrics, and you've got the GPS tracker, which is generating the vehicle location.
Got it. And so you generated this data, right? So this is sort of dummy data that we've set up.
Correct. The actual way that I generated it was using Kinetica's graph solvers to build a selection of routes around DC, and then I just used some SQL functions to generate a data point for a vehicle along each of those routes at a given interval.
Nice. So it's fully baked in Kinetica.
Correct. Yeah.
Can you talk about the UI itself, that what we're looking at?
Yeah, absolutely. So this is Kinetica Workbench, which is essentially what everybody will see and interact with when you first spin up a Kinetica cluster and log in and start to interact with it. We essentially organize the user interface here into data, which is essentially tables inside Kinetica, tables and views, which are like tables inside any other database that you're used to using. You'll also be able to see things like data sources, data output locations, any data streams, any graphs that you've built, any models that you've registered, all here and accessible through this one panel. And where we're going to spend most of our time today is inside a workbook. And anyone who's familiar with using Jupyter notebooks, for example, having this ability to define either text blocks, SQL blocks, map blocks, etc., and build a workflow, a multi-tabbed workflow here, store your SQL code in the cloud, and be able to run through these sequentially and share these out with other users. So this is where we'll spend most of our time, and hopefully get a good feel for that as we go through the demonstration here.
Got it. So do you want to chat through the rest of the...
Sure. So the first thing that we're going to do here is define our tables that we're going to bring this data into. So I've got the two tables I've just talked through, and I'm going to execute the DDL to create these here within these two blocks. Now, where we're actually going to be pulling this data from today is from Kafka, and this is obviously quite representative of these kinds of use cases that are out there in production in reality today at companies, because that will often be used for these continually streaming data sets.
Yeah.
So a great feature of Kinetica is being able to connect to a Kafka's feed, a Kafka topic, directly through SQL. And the way that we do that here is we create a credential. And here you can see the credential that I'm creating for my Confluent Cloud instance, which is where I'm connecting up to get this data from. And then I'm going to use that credential to attach that to a data source. And I'll create two data sources, one for my vehicle metrics, which will be pointing to the vehicle metrics topic, and one for vehicle locations, which will be pointing to the vehicle locations topic. And they'll both use the same credential pointing back to this Confluent setup here. So I'll just run these right now. This won't start any data ingestion at this point.
So this is just defining the data source.
Just defining.
Hey, there's some data here that you can get.
Yeah, absolutely. That's it.
Can we see these on the data tab as well? Is it possible to just quickly on?
Sure. So in the data sources, we'll see my vehicle locations and my vehicle metrics right there. And if I click into this, I can configure and manage this data source from here as well. And there is a user interface for managing data sources and imports, but I'm just using the workbook here to do this.
Got it.
So once my data sources are configured, I can then use those data sources with the load into command. So I'm going to use the load into command into my vehicle locations, into my vehicle metrics, and I'm going to say, hey, go and grab this data from this data source, which I've defined up here. Same for the vehicle metrics.
Yeah.
So let me kick these two off. And we should now have data streaming into our system. So I'm going to move onto the data exploration tab because we've done all our DDLs, we've done all of our data integration, and let's just take a look at the vehicle metrics data. Exactly as we'd expect. We have an ID for our vehicle, and we have some metrics with a timestamp.
Yeah. Vehicle
locations, exactly the same. We have our X and a Y, we have our unique identifier, and we have a timestamp that goes along with this as well.
Nice.
Now, just to kind of complete out Kinetica here, we've also got a view of where these vehicles actually are represented on a map. And this is using a map widget. And I'll just go ahead and add a new block just to walk through what this looks like and build that, what we call a tracks interface here, which is showing not just where a vehicle is, which you can see kind of the head of the snake here, but showing everywhere that it's been on its current journey. And there's a bunch of features that go with tracks in terms of understanding intersections and doing various different geospatial calculations. And it's just a great way to view data moving in space and through time, right? So
are tracks sort of unique to Kinetica, or
yeah, they are. I'm not aware of any other technology out there that allows you to build those server-side rendered views of vehicle breadcrumbs like that, and then also be able to interact with them in the same way. So when you're creating a little map widget here, you're essentially just pointing at a table where you want to get that data from. So I'm just going to point at my vehicle locations. We're going to automatically detect things like the X and the Y columns, and we can select different ways to plot the data, right? So we want to do tracks, but we could be doing class breaks. We could be doing just feature representations, contours, but I'll just select track. And then I can choose various different things like the size of the head, how big do I want the marker, do I want to customize my colors? And I can also set the viewport as well, which we'll come back to. But I just update this, it's going to take me into that view, and this will refresh based on new data arriving into the system.
Nice. Could we make the tracks a bit bigger so that it's easier?
Yeah, for sure. So if I come into the configuration for this, we've got a line width parameter, and I can just crank this up to 7, hit update, and we got a bit more of a chunky line right there, right?
Yeah.
Probably want somewhere in between the two, but that's a good representation, I think. So yeah, I think we've got our data in now. We've seen it. We've explored it a little bit. We've looked.
So it's a very good way to do a quick sense check on the data itself. Right?
For sure.
Hey, is it coming in? Is it coming in the right way? Are all the GPS sort of points where I expect them to be?
Absolutely. Right. And we should probably get onto why we're here today, right? We should talk about ASOF joins, right? Which is, and we're going to use these two data sets. And just scroll up here. You see we've got our timestamps, and we've got our timestamps here for the vehicle locations, and we want to be able to join these two things together, but they're on slightly different timelines, right? We might be getting a data point every 1 second. And we just run this again. We can see that we're now on 3,000 records, for example. So we're getting roughly a record perhaps per vehicle every 1 second, but it's not exact.
Yeah.
So what we want to be able to do is join these two data sets together. So I've got a standard join here, just an inner join, right? Which is join me these two data sets together on the vehicle ID, which is obviously part of it, right? Because we need to match each vehicle to each vehicle. But you can see we've only got 3,000 vehicle metric locations, but when I do this join, we're joining every time series together, right? We're essentially doing this huge
cross product,
right? Absolutely, it's not the result that we want, and we know we can't do the join on time because they're on different time frames, right? So I can't just add into here and vehicle metrics dot ts equals the vehicle locations ts. That just won't work, and it'll produce no results. They don't align, right? So what we're going to do is we're going to use an ASOF join, right? Which is what I'm highlighting on the screen here. And this is going to essentially allow us to join these two different timelines together. And how is it going to do that, right? So first things first, I'm specifying the two columns that I want to compare, which will be the timestamp for my vehicle locations and the timestamp for my vehicle metrics. Now, along with that, I'm specifying an acceptable interval in which I want to count these two timelines as matching. And I'm specifying here between 0 and 10 seconds, right? So, and then finally, we're specifying, okay, if I get a match and I get multiple matches, do you want to take the minimum or do you want to take the maximum in that interval window? So I'm saying here, I want the minimum. Get me the closest as possible to the two timestamps actually matching.
So you're saying, so the vehicle locations timestamp, give me an interval from whenever the GPS point was recorded, give me an interval of 10 seconds from that point, and find me all the hits on the vehicle metrics data, right? So all the sensor information from there, and I want to get the one that is the closest to the GPS point. Got it. Is there any performance benefits to, are there performance penalties to how you describe that interval? Like if you increase the interval to say 100?
For sure. If you increase the interval, you're going to cause potentially more matches, right? So if I change this up to be like a day, I'm back to this scenario up here, right? Where I've actually got all of my rows matched. And
but you're still picking the minimum one from there, right?
You're still picking the minimum one, but you're just asking Kinetica to do more work at that point, right? So there has to be some understanding, I think, of your data here and pick the right interval that works for you. But hopefully that makes sense.
Should we run through these?
For sure. So probably worth pointing out at this point, what we're doing here as well is we're using something called materialized views, which won't be a new concept to most people, but they're slightly different in the way that they work inside Kinetica, because I can add this option here to materialized views called refresh on change. So I'm going to run this, and it's going to produce 6,000 matches, right? Which is much better than the 127,000 or 1.2 million matches that we had above, right? This seems more accurate that we're aligning the correct vehicle locations to the correct vehicle metrics.
Yeah.
And just coming back to this refresh on change, because we're using this materialized view and we're saying on refresh this on change, every time any of these component tables, such as vehicle locations or vehicle metrics, gets new data, we're going to trigger that that refresh of the view, right? So what I'm saying is Kinetica is handling, making sure this materialized view on two streaming data sets, doing a complex function to slam those two data sets together will always be up to date whenever me as a user accesses that data. And you can see from my simple query here.
I have a question. Is it running these? So say every second there's new data coming in. So is the join being computed every second? It's running that.
Yeah, for sure it is. Absolutely. Kinetica's got a lot of intelligence going on behind the scenes, right? We have ways to incrementally refresh these views. We're being as efficient as we possibly can. But the main point for me, there's two experiences that are great here. One, me as a data engineer who needs to give a view to my business users of these metrics with these locations, and I probably should add into here as well the X and the Y, just to complete this data set out and recreate it. And then if we select this, we'll actually have our vehicle locations here with the pressure, compression, and temperature, right? So the two great experiences we've got here is one, me as a data engineer who can set this up once and then never have to worry about doing this again, right? It's just going to continually incrementally refresh. And then there's me who's a user who knows that every time I access this view that's been created, I'm always getting the latest data, right? You can see that 7343 now. I just do a select again, I'm going to get 7727.
Yeah, so you've just sort of taken away all of the sort of other work that you need to do behind the scenes, and Kinetica sort of taken that on, right?
Correct, absolutely.
And gives you high performance while doing that too.
Absolutely, yeah, for sure.
Cool.
Yeah, just while we have it on the screen, there's a little visualization that you can build here within inside the workbook as well, which this is just a bar chart. You can configure the columns and the axes that you want to use and the color schemes, etc. Again, it's just a great way to look at the data, understand things like the spread. And you can see here I've got the different vehicle IDs along the bottom, and I've got the pressure values, which are summed up across the axis through the middle.
Yeah.
So just to complete this out, I think I've got a couple more things to walk through here. You can do whatever kind of complex analytical functions you want in these materialized views, leveraging the power of these ASOF joins at the same time, right? So I wanted to do geospatial functions, I wanted to do ETL, and you can see me doing some basic ETL and data preparation here, just creating some column values, etc., and renaming them to appropriate things. Whatever I wanted to do here, I have the full plethora of Kinetica SQL available to me, things like window functions, etc., etc. Super useful for things like geofencing and detecting whether an object is within a certain boundary at a certain point in time. You can imagine how you can extend this onto a million different use cases, right? So,
and it's also so easy because Kinetica is handling all the work. You can just plug an application on top of this, and it'll just have up-to-date data, right?
Correct. And we're going to show you a little bit of that as well here with Reveal. So I've just ran through a couple more views here, and I've created a dashboard view again with this refresh on change, the same as I've joined some basic ETL in here just to highlight what we're looking at. And I'm going to jump over now into what we call Reveal for anybody who hasn't seen it. And
could you show me that where you clicked in again, just from
sure.
Workbench, just so that I.
So you go to the homepage on Workbench here.
And there's start. Okay, yeah.
And there's start, and that takes you into it. Yeah. So here's my Reveal list of dashboards, and I'm just going to click into the vehicle tracker dashboard, which is something that we've created earlier. And you can see, if I just do a quick refresh here, you can see that we've already gone quite a long way through plotting out our routes. You can see that we've still got real-time data coming in. We're doing some roll-ups of the data here to calculate things like average compression, etc. And all of this is operating in real time, and it's interactive as well. So this is a great use of views because a user can come in, access this data set. They can click onto the map and interact with the vehicle locations. They can understand the pressures and the temperatures, etc., that we're recording as well. And everything here is interactive. So if I want to interact with a specific vehicle, use some of these controls to drill down, understand all the different points. I'm just using a class break here instead of tracks to represent this data, just because it's a bit easier to see. But yeah, I think we've pretty much touched everything we wanted to here.
The timelines button that I see below?
Sure. So the timeline function essentially allows us to replay a data set. So I just turn this up to something like 20, and I can just go back to the start of the data set. And then we're going to play through, and I just zoom into one of these locations up here where we've got a, I'm not too far. I come down to here to my purple guy. We're just going to continually refresh this data set, and you can watch.
Kinetica sort of automatically doing that.
Right.
Just fetching. Yeah, this map widget is just fetching the data.
Correct. Yeah, it's giving you a way to just replay a data set as it happened, essentially, and follow it through in real time. And this works on any data set that has a timestamp, right?
Yeah, it's awesome. This is great. Anything else that you wanted to show us before?
No, I think hopefully that highlights the use of ASOF joins and their function in the way that they're used in use cases like this.
I have I guess, how does Kinetica's ASOF join compare with, say, some other implementations out there?
So there's a few things to bear in mind. Like, Kinetica is distributed, so we can scale to performing these kinds of ASOF joins on huge data sets, right? There's no limit to Kinetica's scale. We're also vectorized, which means that these kinds of operations work incredibly well. They are very parallelized in the way that they're executed, and you would expect to get those sub-second response times on this queries, then views refreshing very quickly without needing a whole lot of compute power. We're very optimized in the way that we execute these, and we can scale to very large data sets.
Awesome. Yeah, I don't have any other questions, so this is great, Matt. Thank you.
Anytime.